This will be your first video, excuse me. This is Chapter 4, the Metric International System. This will be an incredibly important system because it's used in the healthcare system. You will definitely need to read this chapter and work all the problems, understand the differences in the basic units in the metric system, and that's what we're going to talk about today. As you can see here, this name comes from the basic unit of measure, meter, and therefore is called metric system, and it was developed in France a long time ago. France has been using it a long time, as most of the world does, except for America. We still use miles rather than kilometers, and that kind of creates a problem for you as you learn the metric system for the healthcare system, because you must learn it for that. One plus of the metric system is that it is all the units differ from each other in powers of 10. And what we'll be working with is basically 10 to the third power, so your 3 zeros, and you'll see that as we go along. That makes it fairly easy because conversion between the units is done simply by moving the decimal point. The key is moving it the right direction. One of the biggest problems in medication errors is that there's a misplaced decimal point. As you can see here, if you have an order for 0.7 milligrams, and that decimal point gets moved one place over, you have gone from 7/10 of a milligram to 7 milligrams, which is significantly greater amount, and that can cause significant problems in medicating patients. You go the other way, you give them less than what is ordered. The basic units that we deal with are according to length, and what we use for that is meter. Volume, such as when we are measuring urine, or we're measuring their intake, or we're putting up IV fluids, and that unit of measure is liter. And then weight, which is done in grams. You can learn these fairly quickly because even when we begin to add our prefixes, which denote larger or smaller than the basic units, all of the other units have the name of the basic unit in it. So when we're talking about kilogram, we know we are dealing with weight. When we talk about centimeter, we know we're dealing with length. Milligram, again, weight. Microgram, weight. If it was milliliter, we'd know we would be dealing with volume. So all of the terms have the basic unit in the term that you're going to be using, so you can identify what you're measuring. Another nice thing about the metric system is you use identical prefixes with all of the basic metric measurements. Whether you're using meters, liters, or grams, you will use these prefixes. Kilo is the largest. So you've got the largest unit of measure, and it's the only one that is greater than the basic unit of measure. These three are all smaller, than the basic unit of measure, with milli being the largest, and then micro, then centi. Here you've got some examples of those. You've got your gram, which is a basic unit of measure for weight, and then right under that you've got a milligram, which is a smaller unit of measure, and then microgram, which is even smaller than the milligram by 1,000. Then you've got liter, which is your basic unit of measure, a milliliter, which is smaller. Then you've got, we talked about gram up here. Well, a kilogram is larger than a gram. And then with your meter, a kilometer is larger than a meter. So if you need to learn those basic prefixes, and then also this is showing you the abbreviations that we use in the healthcare system. So G for gram, mg for milligram, mcg for microgram, capital L for liter, m, capital L for milliliter, kg kilogram, km kilometer. When using the metric system, the quantity will be written in Arabic numbers, 1, 2, 3, 4, etc. The numbers representing the quantity are placed before the abbreviation with a space in between the two. As mentioned previously, note the space here. Fractional parts of a unit are written in decimal fractions, right here. So we would not write 34.5 milligrams. The correct notation of that is 34.5 milligrams. So that's always written in decimal form. Correct use of zeros is incredibly important. If you have a whole number, or excuse me, you don't have a whole number, but you have a fractional number, such as one of these, 0.125, you always and I emphasize that, place the 0 in front of the decimal point. Otherwise, you can imagine that if you just kind of barely had a decimal point, maybe even less than that, and you put 25 and there was no 0 here, that could be mistaken for 25. Rather than 25 100ths, which is what it actually is. Okay, and then the other thing is we always drop excess zeros following decimal fractions. For example, down here, sorry, I got kind of choked up. 4.500, you do not need these zeros at the end. So they are dropped because 4.500 is the same as 4.5. And that can cause errors in reading the order as well. So those are really important. I will count off if you don't have a 0 in front of a decimal that doesn't have a whole number, and I will count off if you have trailing zeros. When we're talking about units of measure of weights, these are the most common that you're going to use, probably the only ones you're going to use. Kilogram, typically, we mentioned earlier that kilogram is larger than our basic unit of a gram, and normally that is body weights that we use kilograms in. Then you've got your grams. A lot of medications comes in grams. Then smaller unit is milligram, smaller unit than that is micrograms. The common units that you will use for volume are going to be your liter, which is your basic unit of measure, and then smaller than that is your milliliter. One thing you will have to memorize is that there are 30 milliliters equals 1 ounce. And the reason for that is you will do a lot of conversion between household measures and the metric system. Another important one to remember is 5 milliliters equals 1 teaspoon. Just because we do a lot of teaching with that, if you are keeping track of how much a patient drinks, a lot of times they'll tell you they had 4 ounces of orange juice. You've got to be able to convert that to milliliters. So these are the units we use for volume. So when we are converting between units, we are going to move the decimal point 3 places when the units of clinical measure differ by 1,000. When they are side-by-side units, such as you've got your gram, you've got your milligram, and you've got your microgram. These are side-by-side units. Each of these are going to differ by 1,000. So you're going to move the same as the number of zeros. When you're converting from smaller to larger units, so let's say we are converting from milliliters to liters. So we're going from smaller to larger units in the same basic unit of measure. You're going to move the decimal point 3 places to the left. Your numerical answer, or the number you come up with, will be smaller. So let's say, for example, we had 200 milliliters, and we wanted to know how many liters that was. We can take our 200, and of course our decimal point would go right there, and we would move it 1, 2, 3, put a decimal point, and our answer then would be 0, because we have to have that leading 0 without a whole number, 0.2 liters, which makes sense because we're going from smaller to larger, so this number is going to be smaller because we're measuring in larger numbers of units, so it'd be 0.2 liters. Conversely, when you're converting from larger to smaller units in the same basic unit of measure, you're going to move the decimal point 3 places to the right. Okay, I got interrupted, so I'm not exactly sure where I left off. But let's say that we're using the same basic unit of measure, so let's do grams. So let's say we have 0.5 grams equals how many milligrams? Well, we know that if we're going from a larger to a smaller number, our number's going to get, the number of units will get larger. So we will move it to the right. So if we have 0.5, we're going to have to add some zeros and go 1, 2, 3, and put our decimal point there. So we will end up with 500 milligrams is equal to 0.5 grams. Moving the decimal 3 places to the right. You've got a number of these in your book. You need to work all of those. Let me just tell you that the people that work the problems in the book pass the class. The people that don't work the problems in the book either don't pass the class or they barely pass the class. So I would just start out right now with these basics, working all those problems in the book, and then when you come to class, we'll do some practice exercises in class. Okay, med errors are a huge deal in the healthcare delivery system, obviously. They can cause morbidity and they can cause mortality, and they do. They cause people to become sick and have to stay longer in the hospital, and they cause deaths. So we want to be very careful about our dosage calculations, and some of the things related to the metric system is, in terms of errors, is that most occur because prescriptions are not properly notated or they're inaccurately transcribed. And a lot of that has to do with those decimal fractions. So that is why that when we need a zero, we're going to put a zero, such as when we have a fractional number, we must have that leading zero there. Or when there is a trailing zero, we're going to get rid of it. If you miss this decimal point, you could mistake that for 20 milligrams. So we don't need that zero. We just write the whole number. So that's very important in terms of our decimal fractions and avoiding errors. Okay, other things that you can do to avoid errors is if the order or your calculation just seems unreasonable, like and this may not mean a lot to you yet, but it will. Say you come up with 15 milliliters, which would be 3 teaspoons, to give as an injection. That would just not seem reasonable at all, because most injections are not going to be over about 3 milliliters. We'll talk more about that later on. So use your reasoning powers. If it seems to be that it's too small or too large, then question it and double check yourself. Don't forget also that conversion between the units of measure, and we always convert to the very next one. We don't jump from, like, say, grams to micrograms. You want to do grams to milligrams to micrograms, or micrograms to milligrams to grams. We want to do the one that's side by side with that unit of measure. And to do that, we're going to move the decimal point 3 places to get that proper dosage. Okay, do the practice problems. This kind of gives you your lecture, and then when we come to class, we'll actually do a worksheet, but you need to have completed the practice problems.